For nearly 200 years, engineers dared to imagine the unthinkable, linking Britain and France by tunneling beneath the world's busiest, most treacherous shipping lane. Every expert called it impossible, and every attempt failed. Then two nations gambled $11 billion on a 20-meter band of chalk hidden 75 meters below the seabed. If they drifted even a few meters, the Channel Tunnel would become a flooded tomb. How do you thread the needle between ambition and catastrophe? In 1802, a French mining engineer named Albert Mathieu Favier drew the first plan for a tunnel beneath the channel. He imagined stagecoaches pulled by horses, oil lamps flickering in the darkness, and fresh air piped down from the surface. It was a dream as bold as it was impossible. The channel itself was a barrier of myth, a place where storms swallowed ships and tides shifted the very shape of the coast. Still, the idea refused to die. Decades passed. In 1880, engineers on the British side assembled a machine of iron and steam and began to bore into the cliffs at Dover. The Beaumont English boring machine chewed through 842 yards of chalk before politics and fear brought everything to a halt. By 1883, both British and French crews had managed just 3.5 kilometers, and the project was abandoned. The threat of invasion, the unknowns of the sea, and the limits of Victorian technology were too much. Over the next century, the dream kept resurfacing. Each time, new plans promised a link by train, by car, even by moving walkways. Each time, the project collapsed under the weight of cost, war, or suspicion. 4 major attempts came and went, yet every failure left behind something valuable, a little more knowledge of the rock, a little more proof that the chalk marl could be tamed. By the late 20th century, the impossible dream had become a problem waiting for the right solution. The chalk marl was still there, silent and untouched, holding the secret to a crossing that no one had yet managed to build. The Channel Tunnel project began with a single, uncompromising fact. Success or failure would be decided by the rock beneath the sea. The only safe path lay within a band of chalk MRL, just 20 meters thick and buried 75 meters below the seabed. This layer was hard enough to support a tunnel and nearly watertight, but the margin for error was razor thin. Drift a few meters too high and the machines would break into porous rock. The result would be instant flooding, unstoppable and deadly. Drop too low and the heavy clay below would seize the boring machines, trapping them forever. Every meter had to be perfect. A project geologist once described it as threading a needle in total darkness with the weight of 2 nations pressing down. Engineers knew the consequences. A single miscalculation could destroy the tunnel, cost lives, and waste billions. The risk was not just technical, the financial gamble was enormous. In July 1987, Margaret Thatcher and François Mitterrand signed the treaty that finally gave the green light. The terms were clear. Eurotunnel, a private consortium, would finance, build, and operate the tunnel for 55 years, later extended to 99. No government bailout, $11 billion on the line, all riding on the promise that the chalk marl would hold. The design itself was dictated by this gamble. 2 rail tunnels and a service tunnel would run side by side, each one locked into that narrow geological band. The entire project, navigation systems, safety margins, even the choice of machinery, was built around the need to stay within the chalk. Every decision, from treaty to tunnel, was a bet on the rock below, and the price of failure was everything. At the foot of the legendary White Cliffs, the British launched the project with brute force. Engineers brought in explosives, enough to blast 250,000 cubic meters of chalk straight out of the Dover cliff face. The shockwaves carved a new flat base, transforming a sheer wall into a construction platform wide enough to host workshops, track-laying yards, and the massive tunnel boring machines waiting in pieces. The coastline itself was pushed back as millions of tons of excavated chalk poured into the sea. A new 90-acre platform rose from the waves, a man-made peninsula that would become the gateway for trains and trucks to Europe. On the French side, the approach called for something different. Near the village of Sangatte, crews dug a circular pit. 60 meters deep and wide enough to swallow a city block. This shaft became the launch pad for the French machines, allowing them to descend gradually into the perfect chalk layer. The ground above would later be restored, but for now it was a scar on the landscape, a sign that something unprecedented was happening below. Within months, both nations had reshaped their coasts, built their portals, and stood ready to send their machines beneath the sea. Inside the tunnel boring machines, the world narrowed to steel, chalk dust, and relentless noise. 11 of these giants were built just for this job, 6 for the British and 5 for the French. Each machine was a moving factory, hundreds of feet long, with a cutter head weighing 600 tons at the front, grinding through rock day and night. As the cutter jewed forward, hydraulic arms snapped into action, lifting and locking precast concrete segments into place. These rings formed the tunnel wall, sealing out the ocean above. The process was automatic and unbroken. Dig, line, advance. Every minute mattered. On the French side, the machines worked under even harsher pressure.
Sealed face technology kept water at bay in looser ground, turning each tunnel boring machine into a pressurized capsule. The air inside was thick and hot. Temperatures soared to 50 degrees Celsius. Operators wore sweat-soaked overalls, their faces streaked with chalk and exhaustion. There was no breeze, only the roar of engines and the grind of the cutter. One tunnel boring machine operator later recalled that they lost track of time. The only thing they heard was the machine and their own breathing. Steering these monsters was not just about brute force, it was about precision. The entire project depended on keeping the machines locked into a 20-meter band of chalk. No room for error, no second chances. The operator's hands guided the controls, trusting instruments, instincts, and the hope that the rock would hold. Every shift underground was a test of endurance, focus, and nerve.
At 39 kilometers from shore, deep beneath the seabed, the two tunnel faces were separated by nothing but a few meters of chalk. For 3 years, British and French crews had advanced, trusting only the cold logic of gyroscopes and the unwavering line of a laser. There was no room for guesswork. The margin for error was measured in centimeters, too far off, and the tunnels would pass each other in the dark. A billion-dollar mistake locked in stone. On December 1st, 1990, the final pilot hole was drilled. The whine of the drill bit suddenly faded, replaced by a hush as rock dust spilled into the void. Then, in a moment that would circle the globe, a British worker reached through the opening and clasped the hand of his French counterpart. The world watched as two nations, separated by war and water for centuries, were joined by a handshake in the heart of the earth. Instruments confirmed what eyes could hardly believe. After 39 kilometers of blind tunneling, the two faces met with less than half a meter of error. The impossible had been measured, calculated, and achieved. Precision on this scale was not just engineering, it was a triumph of faith in numbers, in teamwork, and in the human ability to aim for perfection and reach it. On May 6, 1994, the Channel Tunnel opened to the world, a symbol of unity, precision, and human resolve. But beneath the celebrations, the project's true cost lingered in the shadows. 6 British tunnel boring machines, each weighing 1,000 tons, remained buried deep under the channel. They were left behind, entombed in chalk, because retrieval would have meant months of delays and millions more spent. The French machines were painstakingly dismantled and brought back to the surface, but on the British side, time and money dictated a different fate. The tunnel's safety systems were put to the test in ways few had imagined. 2 years after the opening, a lorry caught fire inside a truck shuttle train. Flames, fueled by tires and cargo, raced through the tunnel. The emergency response was immediate. Cross passages spaced every 375 meters became lifelines, guiding every passenger and crew member into the sealed service tunnel. Not a single life was lost that night. The ventilation and fire suppression systems worked as designed, but the incident revealed the ever-present danger beneath the channel. For the engineers who built the tunnel, each safety feature carried a story, a lesson written in risk. One safety engineer recalled that they knew the tunnel would be judged not just by what they built, but by how it protected people when everything went wrong. the financial reckoning was just as stark. The final bill soared to over £9.5 billion, nearly double the original estimate. 11 workers lost their lives during construction. Every inch of progress was paid for in sweat, sacrifice, and sometimes tragedy. The Channel Tunnel stands as proof that even the greatest achievements come at a price. Every day, 20 million tons of goods and thousands of people cross beneath the channel. That is evidence that boundaries are only as permanent as our imagination allows. As Europe faces new divisions, the tunnel stands as proof that even the hardest barriers can be engineered away. What will we build next?